Imagine a tiny toothbrush, its bristles barely visible, secretly guiding the formation of a raging hurricane. This unassuming tool illuminates the microscopic beginnings of Earth's most colossal and unpredictable weather phenomena. Imagine a tiny toothbrush, its bristles barely visible, secretly guiding the formation of a raging hurricane. This unassuming tool illuminates the microscopic beginnings of Earth's most colossal and unpredictable weather phenomena. Weather patterns, from gentle breezes to destructive storms, emerge from surprisingly tiny, almost invisible origins. Our planet's atmosphere is a chaotic ballet of air masses, moisture, and countless microscopic particles constantly interacting. These minuscule elements, often overlooked, are absolutely critical for initiating many powerful atmospheric processes. Consider a cloud, a massive structure weighing tons. It begins with water vapor clinging to microscopic dust. Without these minute seed particles, water droplets simply cannot form, preventing any visible cloud development. This delicate balance between the visible and the invisible dictates the very nature of our daily forecasts. Every breath you take contains millions of these airborne particles, constantly circulating throughout the globe. These particles, known as aerosols, originate from both natural sources and various human activities worldwide. Volcanoes erupting, ocean waves crashing, and even trees releasing pollen all contribute to this atmospheric soup. Understanding their fundamental role is key to deciphering the intricate language of Earth's ever-changing weather systems. This complex interplay between microscopic and macroscopic forces shapes everything from local showers to global climate. The sheer abundance and variety of these tiny atmospheric players profoundly influence atmospheric moisture dynamics. Consider a toothbrush's hundreds of fine bristles, each a separate point, yet working together collectively. Each bristle acts much like an individual atmospheric particle, too small to see alone, but crucial when combined. These particles, called aerosols, provide the essential surfaces where water vapor can cool, condense, and eventually coalesce. Just as brushing cleans a single tooth, countless aerosols scrub moisture from the air, initiating droplet formation. Imagine millions of these bristles floating freely, each attracting moisture, forming the earliest, invisible cloud embryos. Sea salt particles from ocean spray are excellent bristles for generating low-level marine clouds. There's more to discover.
As more water condenses, these tiny droplets grow larger, eventually becoming visible as the familiar clouds we observe.
Different types of aerosol eventually becoming visible as the familiar bristles create clouds. We distinct observe cloud formations, influencing sunlight reflection and rainfall patterns. For instance, sea salt particles from ocean spray are excellent bristles for generating low-level marine clouds. Conversely, desert dust or volcanic ash bristles can travel globally, seeding clouds thousands of miles away. The shape, size, and chemical composition of these toothbrush bristles fundamentally alter a cloud's ultimate lifespan. Some particles create small, numerous droplets that prevent rain, while others foster larger drops that fall quickly. This subtle difference profoundly impacts regional droughts or intense rainfall, affecting agriculture and water resources. Therefore, the seemingly insignificant bristles of our atmosphere secretly orchestrate the world's diverse weather systems. Wait until you hear how these microscopic interactions amplify into global weather shifts and long-term climate trends. When water vapor attaches to these bristles, it releases latent heat, which warms the surrounding air. This warming creates updrafts, fueling vertical cloud growth and intensifying storm development significantly. A higher concentration of bristles can lead to more numerous but smaller cloud droplets overall. These smaller droplets are less likely to collide and merge, often suppressing rainfall from developing clouds. Conversely, fewer bristles might mean larger, more efficient rain droplets forming within the cloud. Such changes can significantly alter the amount and distribution of precipitation across entire continents. The precise altitude where these bristles exist also dictates their specific impact on cloud types. High-altitude ice nuclei, specific types of bristles, are crucial for forming icy cirrus clouds that reflect sunlight. Meanwhile, lower-level bristles might contribute to thick, warm rain clouds, essential for local water cycles. Consider how forest fires produce vast quantities of soot bristles, darkening clouds, and influencing atmospheric heating. Even tiny biological particles like bacteria or fungal spores can act as ice-nucleating bristles in cold clouds. These living bristles demonstrate nature's intricate strategies for managing atmospheric water balance effectively. The interaction between various bristle types determines the ultimate fate of moisture within an air mass. Understanding this bristle complexity is paramount for accurate weather modeling and future climate predictions. Ultimately, these microscopic interactions drive the massive weather events shaping our world, day in and day out. Understanding these microscopic processes helps scientists predict weather more accurately, saving lives and protecting property. Human activities release vast numbers of new bristles into the air daily, from industrial emissions to vehicle exhaust. These anthropogenic aerosols significantly modify natural cloud formation, sometimes enhancing and sometimes suppressing precipitation. Such changes can lead to localized droughts in one area, while simultaneously causing unexpected deluges elsewhere. Scientists continually study how these man-made bristles influence global climate, a complex interplay requiring careful observation. Predicting the precise impact of these tiny particles remains one of meteorology's most challenging and crucial frontiers. The humble toothbrush analogy reminds us that even the smallest inputs can ripple through vast, interconnected natural systems.
Every tiny atmospheric particle plays an undeniable role in shaping the very weather patterns we experience daily.
For shaping the very instance experience daily, reducing industrial bristle emissions could alter regional rainfall patterns dramatically over time. Conversely, some propose intentionally adding certain bristles to stimulate rain in drought-stricken areas carefully. This geoengineering concept, though debated, highlights the profound control these microscopic factors hold. The global transport of bristles means pollution from one continent can affect rainfall across another. Therefore, atmospheric research on these minute particles directly informs policies concerning air quality and climate change. Recognizing the toothbrush effect deepens our appreciation for Earth's intricate, self-regulating atmospheric mechanisms. So, the next time you see a cloud, remember the countless invisible toothbrush bristles that made its existence possible. These microscopic elements are crucial, proving that the smallest factors can wield immense power over global phenomena. From a simple mist to a devastating cyclone, the atmosphere's bristles are always at work, unseen.
Their silent influence orchestrates the grand symphony of weather, impacting every facet of our lives.
Intricate dance of impacting every facet of our lives' particles and macro forces defines our planet's dynamic atmospheric identity. The humble toothbrush, unexpectedly, unlocks a powerful metaphor for understanding Earth's complex weather machinery. It teaches us that profound effects often stem from the most minute, overlooked components of any system. So, cherish the unseen, for it meticulously crafts the visible world around us with unparalleled precision. Every gust of wind, every drop of rain, carries the story of countless microscopic beginnings. The true magic of weather lies in this hidden universe of tiny, yet critically influential, atmospheric bristles. If you found this fascinating, subscribe for more incredible hidden science stories and share your thoughts below.